guys, my name is Ayush Bisoy and I'm back with you. The chapter 9 of maths textbook is algebraic expressions and identities. So, as the name suggests, algebraic expressions. So, first we want to know what is expressions. So expressions are a group of terms. When terms are added by a plus symbol or a minus symbol, it's called expressions. And terms are a group of factors are any numerical or algebraic coefficient when they are multiplied. So for example, take there are x and 2, so these are the factors. So if there is x and 2, so this will form 2x. And if there are two more factors, namely 11x and 4, so this will become 44x. 11xy, 44xy. So simply the terms means any two or two more than two coefficients, when they are multiplied, it gives rise to terms. These are the terms. So we get two terms now, that is 44xy and 2x. So these are the two terms after multiplying these both factors. And say for example, the expression is 44xy plus 2x. So this is how we break down the expressions. So what is expressions? Expression is any combination of terms when they are added or subtracted. Terms are the combination of factors when they are multiplied. And factors can be any algebraic or numerical coefficient. Now we'll see what is a coefficient. So coefficient simply means the part of a term. So normally when there is a coefficient asked, it simply means a simple coefficient or a numerical coefficient. So when they ask a simple coefficient, the simple coefficient of any term is the numerical part, the numerical coefficient. For example, 2x coefficient will be 2. If it's 11x, it will be 11. If it's 2z, it will be 2. And if it's simply x, that means it's 1. Every algebraic term has a numerical coefficient. It will be accompanied by a number, or if it's single, that means it has 1 with it. This is the normal basics. Now, the other type of coefficient is the algebraic or the constant coefficient. I mean the variable coefficient. So, algebraic coefficient. The algebraic coefficient simply means the variable part. For example, the algebraic coefficient of 11x is x. 2xy equals to xy. So this is the coefficient. We'll move forward now. Now moving forward, we will be seeing the types of expressions. So the type of expressions are basically monomials and polynomials. So what are monomials? Monomials means when a term has when the expression has only one term. For example, we can have 4x square, 12x, 4y, etc. These are only one terms, and polynomials have more than one term. More than one term. For example, 2x plus 3y plus 1 yx. This is a type of polynomial. This is 2y plus 11z. Even this is a type of polynomial. So polynomial basically means a type of expression which has more than one term, and monomial means the expressions which have one term. And what are binomials and trinomials? They are a specific type of polynomials. So polynomial basically means more than one. So it can have 2, 3, 4, 5, 6, etc. terms. And for being specific, we have binomials and trinomials. So binomials means two terms, and trinomial means three terms. So there are two types of expressions, monomials and polynomials. In polynomials, we have binomials and trinomials. These are the specific, when we want to be specific type of polynomials. When we want to be specific, we talk about binomials and trinomials. Example here we have 23y plus you say 4x square, or we can have 2xy z square plus 3x, etc. And for trinomial we can have this one, the 2x plus 3y plus 1yx. This is a type of trinomial because it has three terms. For another example we can have 4x square y square plus 11x cube. This is a type of trinomial. Now we will move to like and unlike terms. Coming to like and unlike terms, these are very important for addition and subtraction of algebraic expressions. Like terms are the terms which have the same algebra, the same variable within them. So you can see here 7x, 14x and x. These three terms have the same algebraic coefficient. So these are the like terms. For unlike we have 7x square, 11x square yz square and 9x square y square z square. You can see here that this is x square. But the second one has x square, y and z square. And this one has x square, y square, z square. So we can see that in these three, there is not the same um, algebraic coefficient is not there. As this is 7 into x into x. These are the terms. In this, it's 11 into x into y into z into z. So these are not same, and this is 9 into x into x into y into y into z to z. So these are the factors used. Here we can see it is 7 into x, 14 into x, and this is 1 into x. We can see here that all these three have the same algebraic coefficient, but here we can see that all of them have different algebraic coefficients. This is why they are unlike terms. Now let's move forward to the addition and subtraction of algebraic expressions. So moving to the addition part. In addition, we have to keep in mind the like and unlike terms. So for addition, first we will write the first term, that is this, as it is. So what is the question? 9x cubed minus 4x plus 5, and we have to add it with 3x cubed minus 10. So we will write it as 9x cubed minus 4x plus 5 as it is. Then we have to add it with, we'll find out the like terms. So 3x cube is the like term with 9x cube. So we'll write it as it is. Then minus 10. 10 and 5 are like terms, so we will write it as it is. And then now we will use how we find out integers. We have to add these both. So we will get 12x cube. We will write minus 4x as it is, negative 4x. Then now here we will use integers property. So we will take the absolute value of 5 and 10. 10 has more absolute value, so the sign of 10 will be taken, which is negative, and then we have to minus both of them, which is minus 5. So we get the answer 12x cube minus 4x minus 5. So this is the answer. Now we'll take another example. Say for example we take 7xz plus 5xyz minus 3x, then we add it with 4z plus 9xz minus 2xyz, and we will add we will put another term. We will add three expressions in this. We will have another as 4y minus 3xy plus 5. So we'll write the first expression as it is, 7xz plus 5xyz minus 3x. Now we'll find 4z. Has 4z, we have to find like terms, but 4z doesn't have any like terms, so we will write it here. We'll write here 4z. Then 9xz, we have its like term here, so it will be 9xz 9xz minus 2xyz. This is minus 2xyz. So you can see here that we are putting all of these in columns. This is the like terms columns. Now 4y doesn't find its place anywhere. Then minus 3xy, also we can't find any place. Minus 3xy, and then plus 5. Even plus 5 cannot find its any place. So now we'll solve it. We'll add these both. We'll get 16xz. We'll again take the absolute value here. 5 has more absolute value than 2, so the symbol of 5 will be taken as positive, and then you have to subtract them, so it will be 3xyz. Then this will be as it is, as it doesn't have any like terms, 3x. Even this doesn't have any like terms, this will be brought down 4z, and everything else will be brought down as it is, 4y minus 3xy plus 5. So this is the answer of this question. So we can normally see that when we are adding, we have to put the like terms in their columns, and then you have to add or subtract according to the integers property that we have learned. So this is how we solve it. Now we'll move to subtraction. Coming back to subtraction, there is an important thing that we have to notice, that is additive inverse. So while we solve it, we will come to know what it is. So again here we will write the first term as it is, that is this term. But there's an issue. It mentions here from. From means this is the first term. So we have to write this first and we will write this then. In addition, if you change the order, it doesn't matter, but in subtraction it matters. So for that, we have to write this first, this term. 7x plus 9y squared z minus 2y plus 10. Then we will write this one. So it is subtraction 5x 4y squared. This will be 4y squared z 6xy. Sadly there is no xy like term here, so we'll just write it here, plus 6xy minus 3. This will be minus 3 here, and there is no other term present. Now as we can see minus here, so according to the subtraction we have to follow additive inverse. So that means now we have to change these values. So this is normally positive, 5x, as it is nothing is present, that means it's positive. So when we come to the next, this will become negative, this will become positive, this will become positive, and this will become negative. So the sign changes. In subtraction we have to remember that the sign changes of the second number. That's why we said in the starting itself that we cannot change the order of these. In subtraction we cannot change the order of the expressions. That's why now here there are two expressions. If there is three expressions, we have to change the second and the third expressions signs. So after changing the expressions, this becomes negative 5x. So negative 5x and positive 7x will give us 2x. Then this will become positive. Positive plus positive will be positive. So positive. It will be, we have to add these both, that is 13y squared z. Now this will be as it is because it doesn't have any like member, 2y. Now here also this was negative, it changed to positive, so it will be as it is, addition plus 13. and this was plus 6y, it will become negative 6y. So this is the answer that we get after solving this question. Now, if this is a very important topic of subtraction, that is additive inverse, if we miss it, then the answer will go fully wrong. So again, a quick summary, what we have done, we have to remember that there's from. So if from is given, we have to take the second expression as given. If instead of from, it and is given, then you can normally take it like how we took for addition. We have to take the first one and then the second one, but as it is from, we have to take this expression first and then this one. So after that, we write the terms and write the terms as it is, and then after we have to change this sign. We have to change the sign into the opposite one. So here there is no value given, that means it's positive. Positive becomes negative here. This was negative, it became positive. This was negative, it became positive, and this was positive, it became negative. Then after that, we normally use the addition rule, how we have used in the other questions. So after this become negative, we have to subtract these both, we get 2x. After negative becomes positive, we can just normally add them, that's how we do. So it becomes 13y squared z. Here there is nothing there, there is 0, there's nothing. So then it will just normally come down as we have seen, negative 2y. Here again it's the same sign, so we'll just add them. So it becomes 13, and here the sign changes, but it doesn't have any like terms, so it'll just come down simply, negative 6xy. So thank you. Now we'll move to the next part, that's the multiplication part. So coming to multiplication, first we'll be seeing how to multiply a monomial with a monomial, which is the most easiest part, and it is just nothing more than a normal multiplication. For example, now we have 4x into 3. So we should not do anything. We should multiply 4 with 3, that's 12, and then x. It's normal, it's just multiplying the numbers. Then, for example, now we get 5x into 5x. So this is nothing. 5x into 5x will be like 5 into x into x into 5. So this is equals to 25x square. Simple. Now, for example, take 4x into 5y into 3y. Now we will multiply these. We'll get 4 into 5, 20, 23, 60. 60 x y y. So into x into y into y equals to 60 x y square. So this is nothing but a normal multiplication, how we do. Now we'll see how to do a monomial into a polynomial. It's also very similar. So monomial into a polynomial. First we'll see how to do it with a binomial. So it is very easy. Now looking example 3p into 5p plus q. So we know what is the distributive property. It is a into b plus c equals to a plus b. Sorry, a into b plus a into c. So this is the distributive property. Doing a similar thing, so first we have to open these brackets. So opening the bracket simply means multiplying it. So for opening the brackets, we have to multiply 3p and 5p and then multiply 3p and q. So when we multiply 3p and 5p, we get 15p square. And when we multiply 3p with q, we get 3pq. So this is the answer that we get. This is the normal thing. Another question, if we take example 5p q into 3x plus 5, then we'll also do the similar thing, again multiplying both of them. We'll get 15 pq plus 25 pqx plus 25 qp. Qp and pq are simple, same thing. So this is how we get. Again, we will be discussing the same thing. So when we get a question like this, 3p into 5p plus q, first of all we have to open these brackets. For opening these brackets, we have to use the distributive property of addition. So if this is plus, we'll do plus. If this is minus, we'll do minus. For an example, now we will see if we take 3xy in bracket p minus q. So we will get 3xyp minus 3xy cube. This is the answer. So the thing is, if it is minus or addition, whatever it is, here it will be minus and addition. So this is nothing more than a distributive property. So for opening the brackets, that's the main thing I have to do. We have to open the brackets, then we multiply the first term and the second term, and then the first term and the third term to open the bracket. So this is a into b plus a into c, or if it's minus a into b minus a into c. For example, 3p into 5p plus q, we have to multiply 3p and 5p, that's a and b, the first terms, that will give us 15p square, and then the first and the third term, that's 3p and q, that will give us 3pq. Now we will be seeing how to do a monomial with a trinomial. Now we will see with a binomial, now we will see with a trinomial. It's the same thing. For example, let's take 5x into y plus z plus p. This is a trinomial now because it has three terms. So we have to just simply do the same thing. This time multiply with three terms. We have to multiply with three terms, 5xy plus 5xz plus 5xp. So this is the answer, the expressions. So this is also the same thing as binomial. We have to just multiply it with another term. Another example can be 11yz into 5pq minus 3x plus 2z. So we'll multiply it again same. The symbols will remain the same only, the signs. So it will give us 55 yzp cube minus 11 33 xyz plus 22yz square. This will be the answer. So we again see here that we have to multiply it with three terms in the trinomial. Okay, so this is the normal thing of monomial. Now we'll move to how to multiply a polynomial with a polynomial. In a polynomial with a polynomial, first is we will see how to multiply a binomial with a binomial. So the first thing we'll be looking is a binomial into binomial. So when we do binomial into binomial, for example, we'll do 5p plus 3q into x plus 3y. For this, first we have to break this down. We have to multiply 5p with this term and then 3p with this term. So it will become 5p into x plus 3y, then plus this symbol will come here. It will become 3q into x plus 3y. So now we will use how we multiply a monomial with a binomial, the one we learned now. So we have to multiply this and this, then this and this. So this is the way we are going to do 5px plus 15py plus 3qx plus 3qy. This is the answer. The answer will be a bit big. Whatever it is, this is going to be the answer. How this is the way how we are going to solve. So again, we look. It's the same way we did distributive property. We have 5p plus 3q into x plus 3y. So first, we'll take the first term. We'll multiply the second term with each of the first terms. So we'll multiply this full expression with these two terms. So first we'll multiply 5p here, this one, and then with 3q. How we did the first method. So we'll get the answer like this. Now we'll move forward by solving a binomial with a trinomial. Okay, So in binomial with a trinomial, we'll be seeing as this now. A plus 3b into 5y square minus 3x plus 2. So this is also the same way how we were solving first. We'll take this as a full expression, then we'll multiply each of the terms with it. So you get, first we'll multiply a with 5y square minus 3x plus 2, and then plus, you get this symbol here, it will be 3b into 5y square minus 3x plus 2. Again, we solve it like how we did a monomial with a trinomial. We'll do it 5y square a minus 3ax plus 2a plus 15by square minus 9xb plus 6b. Until now, we haven't found a place where there are the same type of we have like terms. So we'll be seeing a question where there are like terms. In the when we find like terms, we should combine them like how we have been doing till now. We'll see some special problems now. Okay, now going forward, we'll be looking at a very simple problem, that is, take for a plus b into a minus b. So we should not do anything, simply a into a minus b plus b into a minus b. So what do? We'll multiply a with this expression, then b with this expression. So we'll get it a square minus ab plus ab minus b square. So what do we get here? We find out that AB and AB, we have two like terms. But what is a symbol? Their symbol is minus and plus. What do we get when we add plus 1? We add it with negative 1. We get it as 0. So whenever we add the same absolute value but with a different sign, it is 0. So here it is AB and AB have the same value but in a different sign. This is the reason why they'll cancel out each other, and we'll get the question a square, we'll get the answer a square minus b square. And this is one of the identities we'll be learning now. We'll see some more extra problems. Okay, now one will be seeing like 5p into 3q plus x plus 9x into 5p plus y. Okay, we'll change this into minus y. So what should we do? We should solve it like normal and then we should add it. So equals to, we will solve the brackets first. We'll take it as in a bracket for separating it out others like this. So we'll get it 15 pq plus 5xp. This is the first thing. Then here plus 45 xp minus 9xy. This is second thing. Now if you open the brackets also, it will be the same thing, as there is nothing else. There is no other symbol for changing the value. But if there is a different symbol for changing the value, then now here if there will be minus, then the brackets will be important. Okay, so now while solving it will be like this. We find that 5xp and 45xp are like terms, and both of them are in the same sign, so we'll just simply add them. So it will be 15 pq plus 50 xp xp minus 9xy. So this is the answer we'll get. Now let us move forward to identities. Moving to identities, first we have to understand what is an identity. Identity is any equation we know that it is an addition of expression like 3x plus 2y equals to, for example, 1 by 3x. It's just a simple expression that has been given. Equation is given. From equation, you can find the value of the variables. So, so the thing is, any equation. Now for this, now whichever value will be given to this x and y, it will not satisfy the answer. So, an equation where any value can be given to x and y, and the answer will be the same. So that type of equation is an identity. Now, for example, we take the example given in a textbook: a into 1 into a plus 2 equals to a cube plus 3a plus 2. So if we try to solve it, we take a as 10 as it's given in our textbook, a as 10. Then as we take a into 10, we'll get 10 plus 1 into 10 plus 2, that is equal to 10 square plus 3 into 10 plus 2. Let's see if it's equal. It's equal, okay. So it is 11 into 12 equals to 100 plus 30 plus 2. It will be 132 equals to 132. Now, if you take any blindly any value for a, still it will be satisfiable because this is an identity. So identity is any type of equation where we give any value to the variable, still the equation is satisfied. Here, if we take a given value to x and given value to y, maybe it will not satisfy and we will not be able to find the correct value of x here. So this is the reason why it is not an identity. So now it is looking at the standard identity. There are three standard identities and one more useful identity that we will be learning in our grade 8. The first of all identity is a plus b the whole square, that is equal to a square plus 2ab plus b square. The second one is a minus b the whole square equals to a square minus 2ab plus b square. Then we have a minus b plus a into a plus b, the one we saw just now for the special problems. This will give us a square minus b square. And here the another useful one, it is not a standard identity but it is a very useful one, that is x plus a into x plus b. Here x will be the constant variable and a and b will be the given constant, equals to x square plus a plus b into x plus a into b. So it is x square plus a plus b into x plus a into b. So these are the four identities given for this year. Now uh, we'll look at this. We'll solve one by one. We'll see some examples also for how to solve them. Now for example, we take x plus 3 the whole square. So when we are asked to find the square of x plus 3, then how will we solve it? We'll solve it as, we'll take it a square, that is x square plus now 2ab, so it will be 2 into x into 3. This is a and this is b, and then plus b square, that is 3 square. So we'll get x square plus 6x plus 9. This is the answer of this expression. So this is how we solve it. We use this expression here, a square plus 2ab plus b square. This is how identities are solved. Now we'll go for another example of another identity. Now say we get 9p minus 3q the whole square. We solve it as it is given, that is a minus b the whole square equals to a square minus 2ab plus b square, that is 9p the whole square minus 2 into 9p into 3q, and then plus 3q the whole square. We'll get 81 p square, the square of 9 and p, minus, we'll multiply these 27 into 54 pq, plus we'll take the square of 9 and q, that is 9q square. This is the answer of this expression. The square of 9p and 3q is 81p square minus 54pq plus q square. Now going for the next one. The next one is a minus b into a plus b, that is equal to a square minus b square. Very important one. This is a very important one. So it will be 3a minus 2b into 3a plus 2b. So it will be 3a the whole square minus 2b the whole square equals to 9a square minus 4b square. This is a very important one, but it's very simple one. Now we'll take a very for wider multiplication, these are very important. For example, now we take the question 297 into 303. This is given in exercises. So how can we demonstrate 297? 297 can be written as 300 minus 3, and 300 plus 3 can be written 303 can be written 300 plus 3. So this is in this form, a minus b into a plus b. So finding the answer of this question, we will use this method. So it will be 300 square minus 3 square. So it will be 90,000 minus 9 equals to 89991. This is the answer. So this is how we use a minus b into a plus b in real life multiplication, and we can do it very quickly. That's why this is very important identity. Next is a very big one, but this is also very important one. X into a plus x into b equals to x square plus a plus b, multiply it with x plus ab. So for example, we take p plus 2 into p plus 4, then we make it equal to p the whole square plus 2 plus 4 into p plus 2 into 4. So we get the answer as p square plus 6p plus 8. This is the answer. Now even this can be used in normal problems, for solving problems that is given in our normal multiplications. For example, 501 into 502. When we multiply such questions, 501 can be written 500 plus 1 into 500 plus 2, and this is in this method. So we will solve it as 500 square plus 1 plus 2 into 500 plus 1 into 2, that is equal to 50000 plus 1000 plus 2 equals to 251002. This is the answer. 501 into 502, we can write it as 500 plus 1 into 500 plus 2. Then using it as this, 500 square plus 1 plus 2 into 500. Oh wait, there's an issue here, sorry. This will be 1500. So this will be 251502. plus 1 into 2, 2. So this is the answer of this question. So this is how it will be important. If you like my video, then please like it and share with your friends, because this is very important chapter, and be ready for my upcoming video on factorization, the continuation of this chapter. So for learning factorization, you need to know the identities and the multiplication of expressions. So please watch this video very carefully. Thank you.